Okay. Yeah, thanks, Kartik. So, yeah, so I'll just run through this presentation today just as a bit of an overview. Firstly, why variable speed drives should be of interest to energy managers. For implementing these or investigating further. So variable speed drive, or VSD, also gets known as a variable frequency drive or adjustable speed drive. It's a few names. Typically, variable speed drives, VSDs, are the most common in Australia. It's an electronic device that's used to control the speed or torque of an AC induction motor by varying the frequency and voltage fed into the motor. So the process really is, so it's 240 volts or 415 volts, depending on whether the motor is single phase or three phase. AC current at 50 hertz is what's the norm in Australia. So that's what's input into the motor, and then the VSD controller then changes that electrical signal to whatever is targeting for the motor's application. So most common, there's a few different types of VSD controllers. There's the most common are pulse width modulation VSD controllers. So they take the AC voltage, convert that through some electronics. So there's a diode bridge and capacitors. Then that goes through to a DC bus voltage, and then the inverters bring it back to an AC signal, and so that's a near sine wave, and then that's kind of adjusted to whatever the application requires. So I won't go into too much more detail around that side of things, but effectively that's a very high-level overview of the process of VSDs. The picture there just shows a range of the actual units. So they, depending on the size of the motor they're controlling, they can vary in size down from a little bit over a shoebox up to giant cabinets for very large motors. So why VSDs developed, and what are the benefits of them? So many motors and pumps, fans that operate on your sites operate with a variable load, so it's not requiring the motor to run 100% all the time. And so there's benefits there in reducing the power of those motors when not required to run that flat out. That's speed and torque adjustments. And so typically or traditionally that control has been done through a range of different techniques, whether that's staging, so such things like different slide valves on compressors, just to effectively kind of throttle the power, or dampeners if it's things like airflows, or control valves for liquid flows. So they've usually been used to control the output of the flow, rather than looking at reducing the speed of the motor as the source of the process control. So instead of using those control measures, using a VSD has a number of benefits for your site. The largest one is the reduced energy consumption. So this is usually what gets these installation of these across the line. Economically, it makes them stack up. But there's also a couple of other benefits there. It often improves your process control, as there's variable loads, there's changing conditions on your site, your process. Gives you a wider, VSTs give you a wider range of control rather than some of these other techniques. And there's also potential extending the life of the motors and other equipment. Usually this is because there's smooth start operation to the motors, so rather than having a large current surge when you start up, you can kind of have a much smoother gradual ramp up into operation. There's also, kind of for the same reason, there's reduced wear on motors as they're not running 100% or even more. There's reduced wear and tear, and then there's also the electrical protection side of things. So it kind of insulates your equipment a bit from under and over voltages and other issues.